Welcome everyone. This is a sprint demo of Indie team. So what we're going to discuss today, we're going to have a look at the current status and the current sprints. Then we will have 3 demos. 2 demos related to SDK sub-project. We'll talk about fully qualified DID support in India SDK. This is a feature that a lot of people were waiting for, and well, finally it's almost done. Also, we are going to discuss the proposal about how the code in SDK and in Aries eventually can be improved. Sergey will tell us about some architecture proposals and using async-await. New Rust features, and he'll show a POC, a demo, how it may look like from the code point of view. And also we will discuss the issue that we found in Sovrin Token plugins and the way how we are going to fix it. Actually, this is the fix is not in plugins. The fix is quite essential change in BLS multi-signature in Plenum. So as for this sprint, let's start with the Indie node team. As you can see, the main focus here is continue doing PBFTV change, and I believe we have a good progress here. So we completed almost all the preliminary tasks before start real integration, and also we added new simulation tests, unit-like simulation tests to make sure that PBFTV change works. Some of the tests are already passed, and we are going to continue this integration process and start replacing the old vChange protocol next sprint. Also, as you can see, this sprint finished a couple of fixes and improvements. In particular, for example, we continue improvements in our test automation, and for example, we added support for load script test analysis. Okay, as for the SDK team, one thing that has been completed is macOS support, the corresponding pipelines, the documentation, and so on. I believe more detailed demo will be done once we issue a new release with this functionality. Also, there is a set of tickets related to fully qualified DID support, and this is what Artem is going to tell us about in a minute. And we've been working on a couple of architecture things related to Aries. For example, this POC that Sergey will show, and some improvements for Aries RFCs. And the final part is our Sovrin plugins sprint, and as I said, the main task here is to fix a tricky issue with the BLS multi-signature for fees transaction, and how it affects the general BLS functionality in Plenum. And this is what Nikita is going to tell us. So Nikita, I'm stopping sharing, so feel free to start.
So here is yeah. So we had an issue with BLS signatures and state proofs for batches when we update multiple ledgers at once. So what was the problem? BLS signature is generated right now on a base of pre-prepare message, which contains right now only one, not state proof, but only one signature for the main ledger of this transaction. When we are sending the main batches with the fees, we are sending only the domain BLS signature and not for token ledger. So when we are asking for a state proof for the token state, or when we are trying to read some get TXN state, it just won't work. Why it was not working? So right now we have, like, for example, 4 nodes that receives a prepare message, and they try to make a commit. they're making a commit. They're making a commit message when we have where we have only a domain signature. Then we are propagating it to all other nodes, and they receive only domain signature. And when they try to order it, and they order it successfully, they save only domain signature, and they do not save token signature. It even have not been formed. So what is the solution? We introduce a new field for commit and pre-prepare. So BLS6 and BLS multisig. And we form and validate these fields on the base of audit ledger. So we are looking for the corresponding audit transaction, fetch state rules that need to be signed, then sign them and put them to the BLS store when we have ordered message. How it works right now? So instead of just domain, we will have domain and token signature in a commit message. So both signatures will be saved and formed, and then we have safe proof working. There one more point that I want to state here, that we will be able to have it in backwards compatibility. With backwards compatibility, so we will preserve the old way when we have only one signature, and we will introduce the new way in parallel. So we, but if we have like 3 nodes with old version of Plenum and 4 nodes with a new one, 4 nodes will send all fields, and 3 nodes will send only old fields. And in this case, I think no new signature will be saved, but old ones will still be saved. And when we get n-f consensus, we will have a new signature saved as well. So we have a test right now that just puts fees or xfer or mint message on a ledger and checks whether getTXT audit proof is working for this sequence number. So let's run it. It will work some time, and it should show that everything is working. And so how it works? It tries to, what's wrong? Maybe, I have no space left. Please. Once again. So how it works? At first, we set up some preconditions, like we are minting tokens, that we are making some addresses, then we are sending some specific transaction is parameterized, so like fees or xfer or mint. Then we try to read this transaction with all nodes responding, and after that we delay all requests for all nodes, for all nodes but one, and try to read just from one node. There we check that state proof is working, so BLS signature is here. So as we see, all tests are passed now, and that's it. We have this functionality working. The most representative here is that we have we can read fees transaction just after we have routed from a single node. That's it.
Thank you. The next demo is from Artem, and this is a demo about fully qualified ID support in the SDK.
Yeah, hello everyone. My demo is about fully qualified ID. So why do we need this? Let's imagine a situation that we have a multiple networks like Indy network, Indy2 network, Indy test, and ELSA, and we as a user would like to act in every them. So if I have some DID in every network, there is no way how I can identify which is a DID belongs to which network. Because in our usual simple form, we just have contents identifier. After changes we did to support fully qualified form, we can identify to which network this DID belongs. Here is the base format of fully qualified DID. It contains all the standard prefix like DID, method name which corresponds to network, and our usual DID base 57.8 string. So to create a fully qualified DID, we need to call our usual create and store myDID function, but we need to provide an additional field method name in the config did info JSON. This method name will be placed as identifier of network. Next, I'm going to show a little demo. It is using Python wrapper. In this demo, I have three participants. I have two issues. Each of them publish the entities to each owner network. Instead of in the pool, I use here just simple dictionaries, but it completely reproduces situation. And I have one prover, which holds two different credentials from every of issues. It can create proof for them. Let's start my sample, and I will comment every step what's going on. Okay, now we did some preparation. We can go further, and now we have the IDs. Each of them is fully qualified. Also, we see issue one created schema DID because its issue DID was fully qualified. Each related entity like schema credential definition also will have the same prefix as the ID. So in the future time, prover or verifier can resolve to which exactly network this entity belongs. We go further. The second issue creates its entities. Yeah. So for this moment, we have two different credential definition. Each of them stored in the different dictionary, and also in my code I have a simple resolver which allows me to get entity from corresponding store. Next, the credential issuance flow doesn't have any changes. It's keep exactly same as before. Each site use identifiers from the previous object. So we don't have any changes here. An important note we have on proof presentation. Because verifier cannot provide some restrictions and it cannot be aware about which credential prover holds, it should specify an additional field, it's called ver, with this field point on what proof we are going to create. If we appoint the version 2.0, we will create proof, we will contain fully qualified identifiers. Else, if, for example, verifier doesn't support fully qualified IDs, we can either omit this field or specify the first version to create a proof which will contain short version of the ID. In my example, I have fully qualified IDs, so I set version 2 here. So we can move next. Proof has been created. if we look on identifiers which presented in this proof, all of them are fully qualified. Go next. Yeah, proof successfully was verified. So it's about LibIndy. One important note also here that Ledger API can accept identifier in a full qualified form, but in output request or response from Indy node, all identifiers always will be in a short form. But it will not affect anyway credential exchange workflow because in only worth fields there is mass values. Next, I would like to briefly tell about how we supported it in V6. It's really easy. The thing you need to do for create a fully qualified ID, it's to add a new field dit method name on provisional config. In this case, agency will create your DID in fully qualified form, and after that, when you establish a connection with the second part, me as example a verifier, I analyze your DID and create a proof of proper format. Now I can start this demo also, just to ensure it works. Run Faber script. Next, we can run Aries script. It takes some time for preparation. We see that the ID is fully qualified. Schema ID is fully qualified also, and credential generation going right now. We have invite details. We send it to Aries. Now connection is established and credential issuance process is started. Yeah, every side sent message to each other. And now, yeah, we can see a proof object which will be sent to Aries. Yeah. And here we can find restrictions which are also fully qualified. And I would like to remember that, for example, if Aries do not specify this method, all her DID will be in short form, and in this case, a restriction will be also short. So that's it from our side. Thank you.
Thank you, Artem, for the demo. And the last demo is from Sergey, and this is about architecture proposals regarding Indy SDK and Aries code.
Thank you, Alex. So I'm sharing my screen. I'm going to tell us about potential changes in our code base. So there's 3 layers in LibIndy, and we have some conversation with community, which part of LibIndy code base should be kept, which part may be moved to Aries. Our architecture is well enough, or there are some places for improvements. And the major concern we ever heard about codebase is the command layer. So let me just start from some background here. By the way, there is a ticket track, the progress, and some link to my POC inside this ticket. So a little background here. There are 3 layers. The first one is the API layer in LibIndy. It's devoted to conversion from C callable API to Rust types. The second one layer is LibIndy comment executor, and the third one is the services. One of the major points of this architecture is to have the service layer and the very useful features of this layer is to have very isolated services. As you can see on this diagram, there's no dependency between services. So each service is just isolated business logic which devoted to particular goal and implement particular features. So it's allow us to have straightforward code in services layer. It's allow us to improve readability of the code base, and of course, it's allow us to have very straightforward test procedure for services. So it simplifies a lot of things. But the cost of this simplification is to have the comment executor layer, and this layer is devoted to split initial comment, which were passed from application via API layer. So comment executor has to split this complex comment to atomic operations, and then use various services, and then aggregate their results to the final result for this comment. And it leads to some complexity in comment executor layer. So let me share some examples in the code base. So I have to switch here. Well, so let's start from API layer. There is, you can see an example for create and storing my DID. Now you can see API layer. It does some conversion from C to Rust. Then create a comment for comment executor, run it to execution, and then waiting for result and perform conversion back from Rust to C and call users callback. So this layer is pretty straightforward and very thin. So we just perform a type conversion here and maybe some basic validation. How it's look on comment executor side? For example, create and store ID uses crypto services, it uses wallet services, and performs some aggregation and return the result. For this particular comment, it may still look more or less straightforward and simple. So we just one by one use appropriate services, we are creating DID by crypto services, then analyze the result of this creation, then using the wallet service to store this, and return the aggregated result to the user. So, and I can show that, for example, the logic at services layer much more complex. So it just have more logic, more line codes, and so on. Here's an example how it looks like for adding entities to the wallet, and there's some internals below it. And also there is an example of crypto service. So it's again contains much more logic against API or comment executor layer. But this proportion is very obvious for a regular comment like create and store my DID. The nuance here that all these service interaction are synchronous, and we don't have to wait some service result for a while. And because of that, it's very straightforward and simple. But if we take a more complex example, like opening a wallet, in this case, to perform just a single operation to open the wallet, we have to create a chain of commands, like starting a creation, then deriving the key. This is a CPU heavy operation. Then we have to continue creation. So it's a complicated the process, a complicated code base of comment executor layer. Like there, so we starting creation, opening a wallet. We have to call wallet services, and then we have to put on pause a user callback to the sum up, then we have to prepare the chained comment to derive key, then we have to call one more helpers and so on. So in fact, there are a chain from different comments, and there is some workaround how to put a user callback for a while, then restore it and use to pass a result. And of course, it's results in some boilerplate. It's not so straightforward. And of course, it's maybe very complicated for newcomers and for new libindie contributor. But there is a solution for this problem. This solution is relies on new nightly feature of Rust. As you may know, there's async-await functionality is coming for Rust, and in this case, open comment would be much more straightforward in the comment executor layer as well. As you can see here, the same wallet open operation now just use one comment and becomes very straightforward, but just use async-await functionality. So it's, as in previous example, in previous flow, still call wallet service for some preparation, then just call derive key function, but its function now await asynchronous, and we have to await the result here. So we can yield to another progress and allow the comment executor to process another comment. But code base here is much more straightforward rather in old approach. So the functionality below these layers are the same as in the current code base. But as you can see, the open operation becomes much more straightforward, and there is no special helpers to continue operation. There is no special chained comments. So I hope this will resolve community concerns about code complexity for this layer. And just to show the proportion, how it's actually reduce the boilerplate, I'm going to also show diff between old logic and new one logic. At the left, you can see the piece of wallet comment executor for open comment. You can see 3 comment here, some macroses, some special queues of callbacks. Again, comments, a lot of helpers function again, separate steps for continue. And at the right side, you can see how it looks for for case when we're using async-await from Rust. It's have only one comment, no special queues, and just one function to do a logic. So in fact, it's the old approach has twice more lines of code in comment executor layer. So it's seems very useful. It's very nice feature of Rust. But I would like to say and remind that its nightly functionality of Rust is not stabilized, and it's the reason why it's not implemented in libindie master code base yet. So we are waiting while then Rust will stabilize this functionality of async-await functions, and as soon as it will be happen, we are going to rewrite our comment executor layer to reduce this boilerplate of chained comments and make it more straightforward and more comfortable for new contributors. That's it from my side. Thank you.
Thank you, Sergey, for very promising proposal. Okay, let me just quickly share my screen again. So, the last part is let's discuss what you may expect next sprint. It will be started on Monday. From the indie node side, we're going to continue working on PBFTV change, and the plan here is to start and have good progress in integration of the new PBFTV change approach. So this is the main goal for the next sprint. For SDK sprint, we're going to continue working on some Aries proposal regarding the architecture and changes and plans on how we can contribute there. Yeah, so we may also evaluate some things about DID doc support or some resolving things related to either Indie or Aries. And for token plugins, I believe there will not be any significant tasks planned for the next sprint. Okay, so that's all. Thank you, everyone, and see you.